Okay, I did not hit going live. So now I am going live. I think. We on now? I gotta hit the go live button. Sorry about that. Let's see, are we live now? Yeah, okay, awesome. So sorry about that. Sorry for running late. What I was saying. Yeah, there we go. Okay. Um, so what I was saying was, I am. This is the homework help office hours. I'm feeling a little bit sick today, so I'm probably gonna keep it a little bit short if not a lot's going on. So just ask your questions if you have any in the chat. Um, and yeah, I have been working on some. I don't know if some of you may have seen. I have Calculus 2 videos starting to pop out. It's going to be like twice a week. They're on mostly Calculus 2 topics, mostly BC Calculus, a little topics that are more for second semester of Calculus. So it'll include BC topics, but more than just the BC Calculus topics if you're taking the AP exam. But all the videos are totally up on my website, the Calculus 2 videos. So if you want to check them out, go ahead. I am. What else is going on? So I need to start putting together questions for the next set of videos I want to do. The next course I want to do. I want to say like a full set of courses. Calculus 3 makes the most sense, the natural extension for vector calculus. However, there may be some interest in physics 2, like E&M type physics, or AP Physics C, electricity and magnetism, like those kinds of problem sets. So if you have any thoughts, please leave in the comments. If you have any thoughts as to what what courses. I do want to do a statistics one and a probability one, some electrical engineering, those kinds of things is definitely on my horizon. So I have like a long-term sort of, plan to make lots and lots and lots of videos. Pre-calculus and back to the older math material for those who need to revisit some of those things. I do want to do at some point. It's probably not going to be for a little bit, but unless there's a lot more interest. But for these office hours, feel free to just bring any questions you might have. Anything that you're struggling with. It can be anything from algebra up to, college math, differential equations, linear algebra. I tutor a number of students in those classes as well, so I have a pretty good sense of those subjects. And yeah, just any questions you might have. I'm trying to find a good way for people to drop in like images of questions. That's another thing I kind of need to sort out and think about is how to handle, like, you have a question, has some figures and diagrams, like how we're gonna upload, put them somewhere. Do I just use a Dropbox or a Google Drive? I don't know. I kind of want a nice, elegant solution. So, I can always do a link to a drive or something like that, a public drive folder people can drop stuff in. But yeah, I'm still thinking about that. But if you do have questions, feel free to start. We'll figure it out as it goes along. But you do have any questions, just ask them in chat, and we can sort it out. I used to do it through a Discord, but yeah, I don't really use Discord much anymore. Because Discord was nice. It was a chat interface that allowed you to drop pictures in and stuff like that. And I thought that was cool. But maybe just email. I have forums up on the website. Yeah, I don't know. Anyway, there's a few ideas. But yeah, any questions you guys might have, feel free to just throw it in the chat. Like I was saying, anything from algebra up to... Some people have questions. I was just with a student just now. I just finished up a session, and we were just talking about... he's electrical engineer, and we were just talking about career paths, emphasis, which direction. So your questions don't have to be homework related, but if you have any questions about, college or engineering, anything, it's really just a chance to ask anything that you want. I want to make myself available to try to help out more people. That's really all I'm doing this for. So if you need any help or if you have any questions, feel free to ask. While I'm doing this, I don't know what else I'm gonna be doing in the meantime. I have like some of these problems I put up here, calculus problems. I'm kind of wary of sort of doing problems sometimes because I'm like, well, not everyone comes here for calculus. I got a lot of statistics students, a lot of physics students. Kind of not sure if I should do some of these. I used to start doing these office hours on Twitch, and I would go through various problems or do some of them. I didn't feel like it worked out too well, so I kind of want to keep it open to whatever it is you guys want to ask, really. So it's going to be more community driven once a community builds up a little bit. Actually have some problems I was going to record a video for. I might as well do it here while I was helping a student with something, just to walk through one problem. So let's take a look at this initial value problem. Typically when you have a first order differential equation like this, it's going to be, you're going to want to put it up like this. You're going to put everything with your dependent variable on one side and everything with the independent variable on the other side, like that. And then we want to use the integrating factor. And the integrating factor that we multiply is always, you look at this, it's the e to the integral of whatever's the coefficient in front of y, or your dependent variable. And that's going to be e to the 7x. We don't need to do a plus c. It doesn't really matter. And then the goal is to do multiply both sides by this integrating factor. So then this is going to be, you're going to multiply e to the 7x by both sides. It's going to be e to the 7x times dy dx plus 7 y is equal to e to the negative x times e to the 7x, which is really e to the 6x. Now the whole reason we do the integrating factor is that this side can be written as y e to the 7x derivative. Because if I do the derivative of this by product rule, you'll get this expression up here. Okay. So then we take the antiderivative, the integral of both sides, to get rid of this derivative. So we get y e to the 7x is equal to 1/6 e to the 6x plus c. Don't forget this constant. And then I can solve for y. So y is then going to be 1/6 multiplying this side by e to the negative 7x. You're going to get 1/6 e to the negative x plus c e to the negative 7x. And then now we have to use the initial value, because we know that at time 0, when x is 0, it should be 11/6. And then plugging in 0 to here, I'm going to get 1/6 e to the 0 is always 1 plus c. So this is going to tell me c is going to equal to 12/6, which is equal to 2. So my exact solution is then going to be equal to 1/6 e to the negative x plus 2 e to the negative 7x, like that. Okay, so that's how you solve an equation of that form. So we have another one that looks just like this, but what I need to do is I need to divide by t squared on both sides to make it look like the same thing. Tx dx dt is equal to 2 over t times x equals t squared, natural log of t, plus 2 over t squared. So I just divided everything by t squared over here, because I needed to, this should be plus. I need to make this coefficient of 1. So then my integrating factor is, I do e to the integral of this part here, 2 over t dt. That's equal e to the 2 natural log of t. That's equal to e to the natural log of t squared. That's equal to e and natural log cancel out, so this just becomes t squared. So this side, I'm going to multiply both sides by t squared, by my integrating factor. So this is going to be t to the 4th ln of t plus 2. And then this side is written, you can write it, it's x times t squared derivative. That's what it will always turn out to be, is this form. And then we're going to integrate both sides to get xt squared is equal to... Now, this one is going to take a few integration by parts to actually figure out. So I wouldn't recommend doing that. I think we can look this up. Integral t to the 4th ln of t. Let me see if I can just find an answer to this, or use an integral calculator to find that one, because it's not like super important that you do it. I mean, I could do it by integration by parts, but it's kind of it's just a little annoying. It's not that annoying, but and then so this integral is going to be let's see, 1/5 t to the 5th ln of t minus t to the 5th over 25, and then that's the integral of this one, and then this is going to be 2t plus c, and then you're going to divide by t squared, so this is going to be 1/5 t cubed natural log of t minus 1 over 25 t cubed plus 2 over t plus c, and then we use the initial value. When I plug in t equals 1, ln of 1 is going to be 0, so that's 0. So this is minus 1 over 25 plus 2 plus c has to equal 0. So that implies c would have to be, what's 2 minus 1 over t? That's 49 over 25, negative 49 over 25. So I think the exact solution then would be x of t is 1/5 t cubed natural log of t minus 1 over 25th t cubed plus 2 over t minus 49 over 25. Okay. Let's see. We're going to do one more. One more by integrating factor. So I'm going to divide by cosine of x because I need it to be dy dx up front, plus y sine over sine x over cosine x is equal to 4x cosine x. And so my integrating factor is just going to be whatever's in front of this y. So it's going to be e to the integral of sine x over cosine x dx. That's e to the, this becomes, what is it? Natural log of cosine. Well, if u is cosine, derivative of cosine is negative sine, so it's going to be negative natural log of cosine x, which is e to the ln 1 over cosine x, which is which is just 1 over cosine x. So then I'm going to multiply both sides by 1 over cosine x, and remember this side's always going to be y times the integrating factor derivative, and multiplying this by 1 over cosine x, I get 4x. So then I'm going to integral of both sides, or antiderivative, is equal to 2x squared plus c. Then multiply through by cosine x, I get 2x squared cosine x plus c times cosine of x. And then using our initial value here, y of pi over 3 is 10 pi squared over 9. If I plug in pi over 3, that's 2 times pi over 3 squared. Cosine cosine of pi over 3 is just unit circle. Pi over 3 is up here. Cosine would be 1/2. So that's 1/2 plus c times 1/2. So this one is pi squared over 9. This 2 cancel with that. So this is pi squared over 9 plus 1/2 c. I subtract this from this side. I get 9 pi squared over 9, or that's pi squared is equal to 1/2 c. And so c is equal to 2 pi squared. So then the final solution is just 2x squared cosine x plus 2 pi squared cosine x, like that. All right. And then was there another question? Let me see. I think that was all of them. Taking care of a few logistics. Let me see. One thing I've had stuck in my head lately, my daughter really liked Frozen 2, and I've been listening to a lot of Frozen 2 music. It's actually pretty good. All right, I was gonna keep it short today, so I'm gonna go ahead and sign off. But I will be back next week. Hopefully, I'll kick this cold. And yeah. All right. Have a good weekend.